So now, as we have already discussed the formula of resistance using Ohm's law, the relation given to us is V equal to IR. Now, what are the other equations that we have already studied in this chapter? First of all, we studied about current, which is rate of flow of charge, and then we studied about potential. It is the source, it is the cause due to which current or charge actually flows in a circuit. So V was defined as work done per unit charge, right? The third formula we got was this. There is another formula that total charge would be equal to that this Q, I write it in capital letter, small letter, doesn't matter, Q represents charge. So charge was equal to n means total number of electrons due to which overall charge is made up of. Now, what we haven't discussed is the SI unit of resistance. So I'll take this formula, V is equal to IR. From here I'll get R is equal to V upon I. From this equation I'm going to represent the SI unit of resistance. 1 ohms, the SI unit is ohm, or it is written as ohm. Okay, so 1 ohm, it is obviously named after the same scientist who discovered the Ohm's law, right? Who established the Ohm's law, I should say. So 1 ohm is equal to 1 volt upon 1 ampere. So how can we define 1 ohm? See, right now this is the symbol of ohm. We always use, for resistance I write this is 4 ohms, right? So for now I'm writing it ohm for sake of simplicity, and now we have to define the value of ohm. So what I can say, the resistance of a resistor is said to be 1 ohm when a current of 1 ampere flows through it after applying a potential difference of 1 volt, or when 1 volt of potential difference is applied across a conductor such that 1 ampere of current flows through it, then its resistance is said to be 1 ohm. You can phrase it any way you like it, okay? So this is the value of, this is the definition of SI unit of resistance, which is ohms. So as we have discussed that how series and parallel circuits are solved, okay, let's solve a circuit.